I'm going to lightning round / marathon this particular video because my kids just keep getting louder and louder upstairs, and then they go outside and they're louder and louder, and I'm not going to be able to handle it. So, what is the difference between this one and the problem we previously did? Well, the problem we previously did, I gave you some pHs, pH and pH. And for this one, I'm given some concentrations. And for the previous one, we could have done pOHs and worked it essentially the same way. For this one, you could have been given concentration H3O plus and worked it the same way. So this will bring things kind of full circle on that. The first part we're asked for is a pH. I don't know what it is. In the previous problem, I knew what it was. It was given as 4.11. So here's a little trick that a lot of people don't realize. Save that for later. You don't have to do things in the order they're given. And I think for many people that's not intuitive. So I'm going to skip right on to part B. Part B asks for a pOH. I don't know that either. So I'm going to move on to part C. Okay? You do not have to do things in order, so do them in a convenient order. I hear the bike squeaking outside. Part D asks for a concentration of OH minus, and that happens to be what we are given. Our concentration of OH minus is 6.1 times 10 to the minus 2 molar. Alright, so we have something. And again, this is like the big trick or the big hurdle for a lot of people. They get stuck because they're not asked for things or in the order that you're going to do them. So, done with part D. What can we get? Well, we can artificially look back at our little flowchart thing here. Although, again, it's not necessary and I don't recommend it. We have a concentration OH minus, which we could use to get a pOH. And that is one of the things that I need. Or I have a concentration of OH minus. I could use it to get H3O plus, and then I could get my pH and pOH. So it doesn't really matter. Since I have this concentration, I'm going to jump right to that pOH, because I know that pOH is defined as the negative log concentration OH minus, which in this case is the negative log of 6.1 times 10 to the minus 2. And we end up in this case with a 1.21 for our pOH. Alright? And we've got options, right? In the previous examples, you were given a pH, and then the first thing I did was get a pOH by subtraction. And we can do that again. There are many ways you can do this, but just so we're doing something. Well, if I know pOH, I can get pH, because I know pH plus pOH should be pKW. And in this case, we've got pH plus 1.21 is 14.00. So 14.00 minus 1.21 gives us 12.79. Okay, we need part C. Since I know a pH, it's easy to get there. Alternately, since I know OH minus, I could use the equilibrium dissociation equation for water, the autoionization equation. But since I have pH, I know 10 to the negative pH is concentration of H3O plus. In this case, that's 10 to the negative 12.79, and we end up with 1.6 times 10 to the minus 13th molar. So 1.6 times 10 to the minus 13th molar H3O plus. That leaves part E. Is it acidic, basic, or neutral? And there are several ways we can come up with this. pH greater than 7, right? In fact, if we look at our hints there from a previous video, pH greater than 7, pOH less than 7 at 25 degrees Celsius, pOH less than pH, this number is greater than this number, sorry, this number is less than this number is greater than this number, at 25 degrees Celsius this number is less than 10 to the minus 7. There's a million different ways to find out that this one happens to be basic. Alright? And that takes care of that one, and let me put a box around that or something. Those are our answers for number 3. For number 4, again, the only difference is this temperature right here is different than this temperature right here, which means these K values are different. You'd have to be given those K values or be given a table from which you could get those K values. But other than that, our basic setup is going to be the same. We're going to have to deal with part A. Okay, well, I have a concentration of OH minus. That's not a pH. I'm going to put that on pause. Part B asks me for a pOH. I don't know the pOH, so I'm going to put part B on pause. Part C asks for a concentration H3O plus. I don't have that, so I'm going to put that on pause. Part D asks for a concentration of OH minus. That is the thing that I have, 6.1 times 10 to the minus 2 molar OH minus. And then E is going to ask us acidic, basic, or neutral. In fact, we could answer that right now. We don't have to, but since that number is less than, in fact, I should be careful here, that number is large enough that this is going to be basic. And when I say large enough, we know at 25 degrees Celsius, when this is 14, 7 is the breaking point for neutral. Well, in this one, half of that, 6.63, would be the dividing line between acidic and basic. We're looking at a concentration that's going to put us with a pH around 1, which is certainly less than 6.63. So basic is the short of that discussion. What do we get next? Well, knowing OH minus, I think it's pretty intuitive for us to get pOH. You don't have to, right? The order is up to you. But pOH should be the negative log, concentration OH minus. In this case, it is the negative log of that number we were given, 6.1 times 10 to the minus 2, which is 1.21. Our pOH hasn't changed because our concentration OH minus hasn't changed. So 1.21 is our pOH. Once you have pOH, or once you have OH minus, or whatever, as I said, you can get this other stuff, and there are many ways to do it. I'm just going to do it the same way we did over here. We said that pH plus pOH was going to give us pKW, and we have this pKW, and I guess I'll utilize some space here. pH plus 1.21 is 13.26 in this case. So we take 13.26 minus 1.21, and that gives us 12.05. So our pH is 12.05. And again, bit of a difference because our K value is different because the temperature is different. And that leaves us with our concentration H3O plus. Again, you could get it from the OH minus or whatever. In this case, 10 to the minus pH. This is going to be an easy way to do it. Concentration H3O plus. And that's going to be 10 to the negative 12.05, which is 8.9 times 10 to the minus 13th molar. 8.9 times 10 to the minus 13th molar H3O plus. And again, if you look at it, pH greater than pOH, it's got to be basic. pH or pOH less than pH. This number is less than this number. Whatever way you want to take note of the fact that this is certainly a basic solution, go ahead and do so. And there are our answers there. I do want to mention in passing here at the end that I was trying to be careful of our sig fig rules. 2 decimal places on the pH, 2 sig figs on the concentration. Decimal places, sig figs, and then the same is true. Decimal places on the pH, sig figs on the concentration. Decimal places on the pH, sig figs on the concentration. In fact, I snuck that in over here. Total sig figs, decimal places for that power value.